Okay guys, so I'm in front of the board right now. I'm going to do the instruction for you guys to fill in your notebooks. And I'm just looking for 2 to 3 really good facts on each one. I'm trying to go straight to the most important ones to make best use of your time. So I'm going to start with, of course, the terrestrial planets, which is right here. And the word terrestrial is a huge hint as to what kind of planets this is, because it is one where we get our word for Terra or Earth. So Terra Lu, as many of you know, is named Earth and Space because those are the root words. But a terrestrial planet is a planet that is defined as very rocky, very dusty. Of course, ours has the formation of soil. This is a planet that you can set foot upon in the most basic of ways, okay? Many times it's going to have wind or dust storms because of how air can move across them depending on their atmosphere. And the terrestrial planets are the 4 that are closest to the sun prior to us getting to the asteroid belt or the Kuiper Belt. I always say it wrong. So those are our first 4 planets that I'm sure that last week when you guys did the solar system distancing lab, you could tell that they were very, very close together. And then after the asteroid belt, they get much further apart. Also, the sizes of these planets is quite similar. Okay, now we're going to move on to the gas giants. And the gas giants are just that. These are massive planets that are built with deep, massive, heavy gas atmospheres, okay? So the entirety of the mass of these planets is found in the gases themselves, which some gases are heavy and some are not, and then also dust and particulate that might also gather around the center of these planets. So these planets, of course, are going to be our big boys of Jupiter, Saturn, and Neptune. All of these are classified as a gas giant, and many of them have multiple moons that are orbiting around them because they have really big masses. And we'll see next week when we talk about the law of universal gravitation what a huge difference that makes in what is able to pull into orbit around them. Also, these planets are a little bit different in how they're structured, and we know that because, of course, of the rings that form around them. Both Saturn and Neptune have rings. Of course, one of them is on their side, and these are ice and dust and rocks, and sometimes very, very large ones that can even break off and become asteroids. Okay? So, moving on to the inner and outer planets. Our inner planets are the ones prior to the asteroid belt. So those there, of course, are the 4 that are closest. And our outer planets are the ones that are outside of the asteroid belt. We saw last week how much further apart and further away those can get. We move further and further into space. The size of the planets, their diameter is much larger on the outer planets than on our inner planets. Also, terrestrial planets are our inner planets, while our outer planets are our gas giants. Okay? Now, let's go ahead and go down here to comets, asteroids, space debris, and satellites. A comet, guys, it's a small celestial body of ice and rock and dust that follows a path that is highly elliptical and actually orbits around the sun. This is the reason why we have the ability to know when comets are coming back around. So Halley's Comet, for instance, we know that will be visible from the Earth's surface about every 80 years. And so in the 90s, a comet called Hale-Bopp came around, and we were able to predict that it would be visible in the night sky because of the fact that it will take a highly predictable path. Sometimes we can see comets, sometimes we cannot see comets. A comet is not a falling star. A comet is not a shooting star. A comet is a completely different astrological body. And most comets originate from what's called the Oort cloud, O-O-R-T. And the Oort cloud is it's a spherical region out in the solar system that extends halfway from here to the next nearest star, which is, it just jumped out of my mind which star that is. Darn it, it just jumped out. But this is an area where basically objects can collide, and when they're colliding, it can break things off. As it breaks things off, it can send that comet into that elliptical orbit around our sun. Okay? Now, let's talk about asteroids right here. An asteroid is a irregularly shaped space rock, okay? And space rock also can orbit the sun. Sometimes they're going to hit things. We know by just looking at our moon, of course, that asteroid hits happen all the time all over the planets because the moon is just absolutely pulverized by asteroid hits. So some of them can be quite small, a couple of meters. Some of them can be incredibly large. We're talking about 30, 40, 50, 60, hundreds of kilometers wide. Of course, we theorize that the asteroid that signaled the end of the dinosaur age was kilometers in length, and that would have caused a huge disruption here on our planet. Asteroids can be made of a couple of different things. Usually it's ice and rock. Some of them are dark. They can be very, very rich in carbon. And in science's future, what they want to do perhaps is to land on asteroids and also mine from them. Scientists theorize that there are really good elements that we can pull off of asteroidal rocks, ranging from gold, nickel, platinum, copper. Metals that form here on Earth also form in asteroids as well. And so we're looking at whether or not we can kind of land on them and mine them, which is really interesting. Now, what I don't have on here and I want you to add to this column are meteoroids, because a meteoroid and an asteroid are very, very different. And then a meteoroid enters the Earth's atmosphere and it can begin to burn up, and then that is a meteor. That's what we call a shooting star, is when we see meteors, or we see a meteor shower and we can see them coming into Earth's atmosphere. They're going to burn up in that upper layer of atmosphere, and then it's going to glow prior to them burning out when they move into a different layer of the atmosphere. And they're glowing because they're hitting Earth's atmosphere and causing a whole bunch of friction, causing them to glow very, very brightly. Okay? Meteorites are going to come all the way to Earth. And again, sometimes they can be quite large. Sometimes they can be small. Sometimes they're nearly nothing because so much of that meteorite has burned out. Okay? Then let's talk about space debris. Space debris is where we have things out in space that are human-made that are just kind of stuck out there, but they don't work anymore. So this can range from different telescopes that we have sent into space to rovers on other planets, to machines that are so far out in the solar system that it's actually caused that machine to go ahead and become non-functional. And that debris is often human-made, or is all the time human-made unless there's aliens. And it can kind of be out there and doing its thing, but we no longer are able to contact it anymore, and nor can we get it back. So things that we have sent into space that we're never getting back, we can classify that as space debris. Then the last thing that I want to talk about are satellites. Satellites are the reason why I can upload this to the internet. Satellites are the reason why we have pictures in clouds, why the cloud exists. And that's because all of that information, from helping us move around with Google Maps to keeping things in a place where we can access it anywhere, is based on satellite technology. So these are satellites, of course, that we have put up into low orbit, close to where things like the International Space Station are. And those satellites have contact with Earth electronically. So this is why our cell phones work. All smartphones work off of satellite technology. That's why we can ping anywhere on the planet. And again, those are human-made. However, we also use the word satellite sometimes to classify things like moons. They can be considered a natural satellite as long as they're orbiting around different planets. So that's everything for our celestial objects classification. You're going to be filling this in your notebooks. I'm not doing a completed one because I wanted you all to watch this video. And of course, if you have any questions or comments or concerns, feel free to contact me. I'll see you guys in the next one. Bye-bye.